Welcome back to our channel Circuit Masterclass, where we break down the complex world of electrical engineering into simple, powerful insights. Whether you're a student, a budding engineer, or just curious about how electricity shapes our world, you're in the right place. In vacuum interrupters, arc forms during both opening and closing operations, which means opening of contacts and closing of contacts. You can think that in a vacuum, there is no medium present, so there is no question of arcing in the vacuum during contact opening or contact closing operations. As we have learned so far, there should be some ionized medium between the opening or closing contacts to initiate arcing in the contact gap, but in a vacuum, there is nothing. So, no question of ionized atoms or molecules or ions in between the opening or closing contacts. So, if there is no arcing, then the current interruption in vacuum can be instantaneous. The vacuum technology interrupts the current instantaneously. There may be a problem of current chopping in the system. We know that current chopping causes the surge voltage in the system, which can create failure of the system's insulation. So, we have to avoid current chopping. All circuit breakers interrupt current without chopping it. The main target of a circuit breaker is to interrupt current without chopping. In vacuum also, the arcs are formed, but in a different way. It is called a typical vacuum arc. Now come to the arc formation during the opening operation. Actually, when the contacts open in a vacuum interrupter, the current is concentrated at a very narrow region. So, there will be very high current density, and that current density will cause the vaporization of metal from the surface of the conductor because it is a vacuum. So naturally, the metal can get vaporized more easily than at atmospheric pressure. As per the rule of nature, the contact surface becomes a point before it will finally detach. And during this process, the current has to pass. That means the fault current has to pass through that narrow region during final detaching of contacts. And due to this narrow region, the temperature of that spot will rise and a hot spot will be created, and the temperature will cross the melting point of the metal of the contact surface. Moreover, the surrounding is vacuum, so the metal can more easily be vaporized. Due to the high voltage gradient or voltage stress between the contacts, this metal vapor gets ionized, and this ionized metal vapor creates a plasma. And through this plasma, a vacuum arc is sustained due to the strong electric field and due to high temperature. There will be both field emission and thermionic emission from the cathode surface. There will be certain spots on the contact surface from where electrons will emit due to field emission and thermionic emission. And these spots are called cathode spots. And due to this emission, the plasma will sustain, and as a result, the current will pass through that plasma and create an arc. That means the arc sustains. There are a number of arcs created on the surface. For low current, less than say 10 kiloampere, there will be a number of arcs formed between the contacts, and when the current increases due to magnetic force, better to say Lorentz force, these all arcs come together to create a thicker arc, a thicker and stronger arc, and that will affect the contact surface because the heating is concentrated at a single spot instead of diffusing the arc all over the contact surface. As the contacts are gradually separated from each other, the dielectric strength is increasing. As the contacts are gradually getting separated from each other, the required voltage to sustain the arc is also increasing. In other way, we can say as the contacts are going away from each other, the voltage gradient between them is decreasing accordingly. So, at the zero crossing, the current will be discontinued and the plasma will be weaker. And as a result, the arc vanishes, and at that instant, the metal vapor gets condensed, so the vacuum is again established, and thereby the dielectric strength in the contact gap is again established.
Because of this, the current cannot reignite during the next half cycle, and the current gets finally interrupted. However, due to restriking, a few more cycles may occur before it is completely interrupted. Now, regarding the arc phenomenon during the closing operation. When the moving contact comes very close to the fixed contact, there is a micro-discharge before the contacts physically touch. This happens due to a very high voltage gradient or electric field. The electric field strength becomes very high when the moving contacts approach the fixed contacts. As a result, field emission starts between the surfaces, creating micro-discharge. This occurs due to the high voltage across a very small gap, causing field emission that creates current continuity from one contact to another. This raises the temperature, causing metal to vaporize and form a plasma column, thus forming a pre-strike arc. During closing, only field emission initiates the arc, not thermionic emission, which occurs during opening. Arc quenching here is simple. When the contacts finally touch, the arc is automatically quenched. Opening arcs are generated due to both field emission and thermionic emission. Closing arcs are generated only due to field emission, because there is no hotspot formed before the contacts close.
If you found this helpful, don't forget to like, subscribe, and tap the notification bell so you never miss a voltage boost from our channel. Got questions or want us to cover a specific topic? Drop it in the comments. We read everyone. Thanks for watching. And as always, stay grounded, stay curious, and keep engineering your future. See you in the next one.